Today, as mentioned in the agenda, we'll be going through introduction into Git and introduction to Terraform. So, before I start, I would like to hear from you. What is your understanding with respect to Git as a tool? Can someone come forward and tell me? Okay, basically it's a distributed version control system used for tracking changes done by software developers and sometimes infra engineers, DevOps engineers, QA automation engineers for the respective code changes. It allows you to do version control as well as you can track your version history, and you can also create branches. You can start working on merging, and it also allows you to collaborate between the team members. Basically, this allows you to do collaboration and makes you efficient, and there is no need to think about whether the code is saved or whether the code is deleted by someone else. So you don't need to worry about integrity within the team. In order to maintain the integrity, also you can use Git tool for source code management. Apart from usual activities, it also has ability to do continuous integration and continuous deployment. We'll see how it helps you to do CI/CD. Okay. Any questions? So moving on to the operations. The basic operations include a git config that we have already done to configure your git git local machine to have the username and password, username and email, so that when you make changes, when you push your commits to the remote repository, that has reference to your username and email ID. Git clone basically creates a local copy of the remote repository. It basically downloads the files and necessary branches and everything into your local machine. Any idea what git pull does? Can someone quickly answer? Git pull. Aishu? Zafi? Shweta?
It will fetch the data into the Git.
Yeah. It basically downloads the latest code changes to your local repository. It fetches or pulls that information from the remote repository and saves in your current local repository. Okay, what is git add? Basically, it stages your changes to the local repository, and then it allows you to do a git commit, save the changes, and as soon as you do a git commit, it will create a git commit ID for you that will be unique. And based on the commit ID, you can understand what changes, based on the commit message, you can understand what kind of changes you made for that particular commit. Git push is Git push is a command which pushes the actual local code into a remote repository, and merges your changes. Git checkout is basically to pull different branches from the repository. For example, you are working on a development branch, whereas you want to check out a new feature branch, or you want to work on other branch that people in your team working on it, you can do a git checkout and your branch name. So this is kind of a Git client. Whatever we saw, the Git commands, that is at the client level. What is at the server level is the Git repository, which is actually hosting your GitLab or GitHub repositories. So there are two major providers for GitLab, whereas GitHub is one of the popular repository. GitLab also provides different options for CI/CD, issue tracking, and various other tools like environment creation and managing the CI/CD pipeline. So there are two different authentication mechanisms. One is HTTPS, another one is SSH. So HTTPS requires always a username and a password to log in, and you require to be providing the password and username and password every time when you do a git push or git merge. Whereas if you use SSH based authentication by copying the public key to the remote repository server, you never need to type the password, you never need to interfere and then type the password. It will be passwordless authentication every time when you do a git pull or git push. So like I told you, in SSH authentication we use public key and private key. Private key will be in a local machine in the .aws SSH folder, sorry, .ssh folder, whereas public key will be copied to the repository settings and SSH key section. So HTTPS authentication always requires a credential to be passed on. So that's the reason why I avoid, because I mean, as a DevOps engineer, you are supposed to be quite efficient and save time while you are doing tasks. Can someone answer me? What are the different teams within the organization uses Git? Just give it a try. Sindhu? Hello? Can you speak out?
Is a development team that is a software developer or full stack developer team.
Okay. See, in the DevOps world, uh, with the current scenario, people from people from different teams, like DevOps team, QA team, release management team, everybody uses Git as a tool to manage their source code. For example, infrastructure automation engineer who was writing Terraform code, he will end up having a source code management and a repository in GitLab or GitHub. He will store and retrieve the code in GitLab. So it's not only developers, QA for their automation, like kind of Selenium automation or robotic process automation. They will use Git for their source code management. Okay. One of the important Git operation that triggers a pipeline is your Git push operation or a Git merge operation. Any idea what is the trigger? Shiva, you can probably comment on it. What is trigger? Trigger in the CI/CD pipeline. So
Yeah,
trigger is basically an action. Yeah.
Are you able to hear me, Shankar?
Yeah, I'm able to hear you. Yes.
Yeah, whenever the code has been updated, automatically it will trigger the pipeline.
Trigger is basically an action or as a result of a particular action. So whenever there is a push happens, automatically it triggers a pipeline. It also goes through with merge operation. Any questions? And the most important thing for a DevOps engineer or any developer, before making any changes in their local environment, they have to do a git pull to update the code with the latest changes in the remote repository, because there are chances that at the same time developer A or developer B working on the same code, and they would end up updating the code changes and pushing their code changes. So as a developer C, you are supposed to always pull the latest changes and then start working on your code. Okay. Any questions so far for Git? Okay. So Git config command that we saw in the day one to create the configuration information global as a global variable like user.name and user.email. And use of public key and private key. This is basically to allow you to do all the operations from the command line in Git Bash. So how SSH key works? One more thing before that. There is a file called .git folder. Underneath you will have a config file which has information about your repository that you checked out, that you are working on. So if you look at this one, how SSH authentication works, uh, private key from your local machine is nothing but a secret key that sends authentication. I mean, indicates that there is a SSH connection trying to connect you, authenticate you. Then it sends a hello message, and again that is encrypted and sent to the public key. If public key is able to understand that information, that means it can decrypt that particular information. That means the public key and private key are matching. That's why the authentication is passed. After that, you can do a push pull, whatever you want, you can do it to the remote repository. So some of the operations that I am trying to explain here. Git init usually does initialize the Git repository in your project directory. We don't do this because we directly create the repository in the remote server and then we do a Git clone. Git clone actually downloads the repository to a local machine, and then on you can make changes to your local repository and then do further changes like git add, git commit and git push. So git status and git diff are most important to understand what changes you have done with respect to the existing files. Git status will show you what files have been modified. If it is modified, it will show you modified. If it is a new file, it will show untracked. Git diff will show you what lines have been added, what lines have been deleted, like that. So plus symbol will be there if there is an addition, minus symbol will be there if there is a removal. At the same time, plus will be with the green, minus will be with the red. All the removal will be with the red. So git push, as I said, I mean it uploads your changes to the remote repository. Git reset is to reset your local changes, whatever last commit that you did. I mean you can reset to the reset and then go to the older commit. Git pull is to fetch and merge the changes to the local repository. Git checkout is to check out a branch. Git branch is to create a new branch. Git checkout also we can use to create a new branch. Git merge is to merge your changes from one branch to the another branch. Any questions so far? So you can see that there are 3 steps towards, 2 steps, but 3 different areas. Working area is your local branch. Staging area is also your local branch, local repository. And third one will be your Git repository. So before adding any changes, it will be in your working area. Once you do Git add, it will be in the staging area. And after you commit, it will be indexed and it will be saved in your local repository itself. But when you do a push, it will go to the remote repository. So this diagram simply shows exactly the same thing. When you do a git pull, it becomes a working copy. When you do a git clone as well, it is a working copy. Whenever you push from your local repository, it goes to the remote repository. Okay, that's all with respect to Git. If you have any questions, feel free to ask me now. Any questions from anyone? Aisha, are you there in the call still?
Yes, sir.
Okay. Any questions with respect to Git?
No, sir.
So Git operations, we'll be doing it on a daily basis once we start working on writing Terraform code. We'll be doing Git add, Git commit, Git push, Git pull, things like that. We'll be start doing. Anyways, we'll have a dedicated session for dedicated 1 hour session for Git alone, along with some changes in the Git Terraform code. So, what is Terraform? How many of you can answer me? So, in order for any DevOps engineer to work on, there is an environment which is required. For example, it will be an EC2 machine, or it will be an S3 bucket, it will be an RDS database server. So you require to write everything uh, in a code format, so that that can be maintained, can be used by teams, reused by teams, so that infrastructure can be created, modified, updated, and deleted whenever it is required. So instead of going to AWS console, you can modify everything from your local file system. That means your code repository. So how do you create resources is like using the Terraform command. You can say Terraform apply, and whatever .terraform.tf files uh, you created, based on the .tf file, all the resources will be created, or all the resources will be updated in your AWS cloud. So this basically, you can basically use authentication by giving access key and secret key that you can provide in the provider block, or you can use the access key and secret key which is there in the .aws folder, which is created by running AWS configure command. Basically, it automates the provisioning, uh, updating and deleting of resources in AWS cloud. So it also supports different clouds, for example, AWS, Azure, and GCP. However, there are other infrastructure as code tool which are cloud native. For CloudFormation, for AWS, it is CFT, which is called a CloudFormation template. For Azure, it is called Azure Resource Manager. That will act as an infrastructure as code tool for only for Azure based resources. Similarly, for the GCP, you have CDM, which is Cloud Deployment Manager. However, I mean, if you use, most of the companies are using Terraform as infrastructure as code tool because it is cloud agnostic, and at any time, if you want to shift from one cloud to another cloud, you can simply do a Terraform migrate and some minor changes to the cloud source code, and you will be able to migrate to a next cloud. There are different stages while running the Terraform code, that is init, validate, plan, apply, and destroy. And there are different blocks, basic blocks, provider block, variable block, data block, resource block, and output block. So provider block defines your cloud provider and your authentication details and region details. Whereas variable block is basically to create custom variables and its values based on your environment, based on your resource. Data is to fetch information from the existing resource and use that information while you are creating other resources. A resource block is the one which actually creates the resources in AWS cloud or any cloud, be it a virtual machine, be it a VPC, be it any other resource like a database, Redis cache, S3 bucket, whatever it is. Output is a block which gives you output of whatever resources that has been created as a result of apply. Any questions so far? At least make it interactive, guys. Please talk.
No, sir.
Any questions?
No, sir.
Okay. So what is Terraform state file? Anybody has a clue?
What state the file is? So like that. Sir.
Yeah,
We have a
basically,
init apply. So
okay. Basically, it stores the information or the status of the existing cloud resources that has been created by Terraform apply command. Basically, this file is getting created after finishing your Terraform apply command. So this gets created and it acts as a reference for your next Terraform apply command or your Terraform destroy command. So based on this one only, your subsequent apply or destroy command will work. So this is nothing but a database file which contains information about your resources that are created by Terraform apply command. So when you are doing it from the local machine, it will be stored in the local machine in your local file system. Whereas if you're working on the CI/CD pipeline, for example GitLab or GitHub, you need to use S3 bucket to store your state file so that it can be used by referring to the particular S3 bucket instead of referring it locally, because if you are running through GitLab CI or GitHub, you will not be able to refer to the local machine because you will not have connection to the local machine. It will be running on a different medium altogether. When I say GitLab CI, that means it will be running on a GitLab server. It has no connection to the local server, no local machine. So in that case, you need to either use S3 bucket or any other artifact. Like GitLab also provides an artifact. There you can store it and run it. Otherwise, the most preferred way is to storing them in the S3 bucket. So what is .terraform folder? This is the folder which is created when you are running Terraform init command, which stores all the plugin information, all the softwares that are required to connect to your AWS cloud. So I'm moving on to the next and the last section of today's class. What is a DynamoDB log file? Why is it required? DynamoDB log file is required when multiple people are working in the team who are trying to modify the same information and trying to push trying to do apply command. So when multiple people are doing the apply, it is supposed to be locking the file, locking the state file, so that that state file is not overwritten or modified by other people. For that, you can use DynamoDB, which is another database server which is provided by AWS. Using that file, you can log the state file which is there in S3 bucket. It will basically create a table, um, and then it will log the state file, and it will be released only when the apply is completed. Any questions so far? The Terraform PPT. I'll go on to the slideshow. So like I already explained, we heavily use AWS CLI or Terraform for creating resources. Both works in the same way. There are two different kind of operations. One is write, another one is read. In the write operations, most of the common operations are like create, modify, delete, and update. Whereas in the read operations, we usually do get some information from the existing resources that will be describe, list, and get. So describe usually doesn't require any parameters. Create requires all the necessary parameters to create a particular resource. So modify and delete will require existing information, whatever resource that is already created, that information you need to pass on. And list requires at least one parameter for you to get some information. So similar to that only, most of the Terraform operations will happen when you create resources or when you modify resources. So another thing, whenever you run AWS configure, it stores two files, it creates two files. One is in your home directory, you will see .config file and config file and credentials file. Credentials file stores your access key and secret key, whereas config file stores your region and format of the output. Here the information is stored in plain text, so it is important to protect your system from others to log into the system, so that you don't share this information to others. And at the same time, you are always be very careful. Don't share this information to anyone outside. Don't keep this information in a public repository in GitLab or GitHub. If it is a public repository, your information will be easily stolen, and they will bombard your bill. There is a possibility you can get back to your account by raising a request, but it is always advised not to share any of your credentials in the public repository. Any questions? How many of you executed AWS S3 LS, AWS BC to describe instances commands so far? Please say yes or no with your name. Zafi?
Yes, sir. I did.
Good. Okay. Sindhu?
Yes, sir. Executed, sir.
You did it, right? Aishu, you remember you did it? These commands?
Yes, sir. Yes, sir.
Okay. Okay. Moving on to the Terraform that I already explained. It is something similar to JSON. If you have not learned or maybe haven't seen how the JSON format looks like, please go back and spend some time to read about how the JSON file should be written. So it's the format here is called HashiCorp configuration language. It is HCL. It is a plain text format. Kind of you use only curly braces to create a block of code. Otherwise, it looks pretty simple. 5 different stages: init, validate, plan, apply, and destroy. Different blocks: provider, resource block, and you require access key and secret key in order to connect with the resource AWS cloud. One of the most important thing that you need to understand is whatever resource that you are creating, you are trying to create, you are writing a script, it should be with .tf extension. Then only when you run Terraform init, plan, or apply, this file will be considered. Otherwise, file without any .tf extension is not considered. So here is the architecture of Terraform. So as a DevOps engineer or the infra engineer, you start creating the .tf files, which is nothing but your Terraform source code. That source code will be compiled and then executed against your AWS cloud or Azure cloud. And based on the provider, it will talk to the particular cloud, and once a resource is created, it updates a state file, Terraform state file. Any questions, anyone?
No, sir.
Okay. So init initializes your working directory, and that will contain all the configuration files. Validate is a inbuilt validator which will validate the format of the file and syntax error, whatever it is. It will validate and then give you go to the next level. So then you do a Terraform plan, which is basically execution plan or an example of what it is going to be created. Before you actually create anything, what will be the decide state that you can understand by running the plan. So it makes you aware that what is going to be created or what's going to be deleted. If you're fine with it, you can go ahead and then do a Terraform apply so that your changes can be applied directly to the cloud. And whenever you have some holidays, whenever you have some non-working hours, maybe your testing is completed, your environment can be removed, you can do a destroy by running Terraform destroy so that all the resources that you created is removed. So this basically we do it because when it is not in use, we can destroy and save cost irrespective of any cloud you are working. This is mostly useful if you are working on a cloud pay as you go model. So when you destroy, your complete resources will be removed and there will be absolutely nothing in your bill. Okay, here we'll be looking more into the different blocks, how blocks are written, what are the different keywords that you need to be aware of. The first block is always in green. Sorry, I have written in green, which is without any double quotes or single quotes. That you have to really make sure. The first block, first column should always be your AWS related one, or it's a Terraform related one, which is nothing but either a provider or a resource or data or variable based on whatever block that you define. That should be written always without any double quotes or single quotes. The next column would be the second column that will have a specific information specific to your cloud. If it is a provider, AWS provider, it will be AWS. If it is Azure, it will be Azure. It will be, if it's a Google cloud, it will be GCP. And if you are creating a VPC, it will be AWS _VPC. If you are creating an instance, it will be AWS underscore instance, and only for the provider block and variable block there is no third column. Even for the output there is no third column. But with respect to resource, you need to mention what is the resource name, so that this resource name can be used to call and use it in another resource. For example, if you are using VPC resource in other resource block, you can use AWS underscore VPC dot main underscore VPC to refer to this particular VPC VPC ID. So similar to this one, where dot access key, right? It is the reference to the access key that is created in the variables block. Where is pointing to the variable object. So whatever is created using variable that is a var object, var dot access key. So you are calling the access key variable object and then replacing it here. It is something similar to if you would have written Python program and say a equals 12 and then b equals a, something similar to that. You are using object notation to call the object and object the variable inside an object. So second column is fixed, third column is a variable that is based on your own definition. It can be main VPC, my VPC, my first VPC, anything it can be, but you should not keep any space. You should always use underscore. Okay. So here we have a data block which is actually selecting the existing VPC based on the tag name and values. So data.aws underscore VPC dot selected will be your VPC ID that you can use it anywhere, wherever you need to pass VPC details. So similarly, variable block, how variable block is written, you just define a variable name, AMI ID, and variable value in the default parameter. So this one description is just for you to understand what kind of variable that you are creating. Similarly, it goes for instance type. Instance type you might have used t2.micro or t2.medium. So you create a variable name and then variable value in the default section. So in the output block also, you can just get the output address by defining your variable name, and then you should give the object notation dot your object dot and your attribute. So whatever is after the object, it is called attribute. Whatever is the first one, it is called object. AWS instance is an object. From there, you are trying to call the attribute server and then private IP. So how do you define an object? You can say variable name, resource, also resource, AWS underscore instance, and then your resource name. Like that also you can create. Similarly for the public subnet, you just give a name as public, but whereas based on whether it is associated to the internet gateway or NAT gateway, it becomes a public subnet or private subnet. So we'll again connect Terraform and AWS resources, and we'll go one session for specifically to VPC and network resources. Merge is actually used to combine two values. That's when merge is used. Otherwise, you will mostly use simple object notation and then attribute. So this is with respect to the CI/CD. This we'll see maybe in the upcoming class by end of this week mostly, because we'll end up writing pipeline YAML file which will take care of taking your changes directly to the AWS cloud and run it for you. Instead of you run Terraform plan, Terraform init, Terraform apply, plan and apply, GitLab will take care of running it directly on the AWS cloud and create resources for you as soon as you make some changes in your code base. Okay. With this, I'll close my screen. I'll go over everyone to have a question and QA session. Anybody has questions? Tell me if you have understood my session. Is it clear to everyone? Sindhu?
Yes, sir.
Because I'll send out a questionnaire after the class. You are supposed to write answers for them and then submit again tonight, before tonight or before tomorrow's class. So please ask questions if you have any doubts. Zafira?
Yes, sir. No doubt, sir.
Okay. Aishu left because probably her phone is switched off. Any more questions? Shiva, if I missed anything, please elaborate something to them.
No, Shankar, you covered everything. And do you have practical session also, like writing a Terraform code and all?
That I'm not doing it today. I'll let them do at their home first. Maybe we can do it tomorrow.
Okay, got it.
I will let everyone go through basic Terraform code blocks. Maybe you can make a note right now. How to create VPC, how to create S3 bucket, how to create a subnet, a VPC subnet and S3 bucket. Write code blocks from Terraform using Terraform. Hope you have understood. Shweta, you are there in the call.
Yes.
Okay. So just make a note. Write a Terraform code which is nothing but a .tf extension. You can write it as main.tf. You can write a code block for VPC creation, subnet creation, S3 bucket creation, and EC2 instance creation. All of them put it in a single file or maybe separate files. I think it is better to put EC2.tf, VPC.tf, subnet.tf, S3.tf, like that, 4 different files, and push it to your GitLab repository, whatever you have created yesterday. You create a different folder and push it there and share your repository details. Okay.
Okay, sir.
Don't copy paste from internet. Even if you see something in the internet, just write it down in your maybe in your VA editor or in your personal editor. So don't copy paste the code from internet. At least read the stuff and try to write it on your own. Okay. Okay.
Yes, sir.
That's all I had. Anything else? Any questions from yesterday's session?
No, sir.
You're clear on that? Whatever you learned so far?
Yes, sir.
Sure. If you are not sure, if you have any questions, ask me. Otherwise, you will have difficulties in the upcoming sessions. Okay. Okay. Thank you all. See you. See you tomorrow. Bye.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you, sir.